All right, welcome back. Today, we've got a really cool story for you. A story about a chemical hero, an antidote designed to fight one of the most famous and feared poisons out there. It's a fantastic tale of chemistry, medicine, and the incredible, relentless march of progress.
So, let's just jump right in with a pretty high-stakes question. Imagine you are up against a fast-acting, lethal poison. The clock is literally ticking. Every second counts. How in the world do you stop it? How do you reverse its effects? That's the huge problem we're going to unpack today.
All right, first up, every good story needs a villain. And in this case, the villain is a particularly nasty one. We're talking about cyanide poisoning. This is an absolute code-red medical emergency. This stuff works terrifyingly fast. It basically gets inside your body and tells your cells they can't use oxygen anymore. So even with air in your lungs, your body is suffocating on a cellular level. It's a rapid, systemic shutdown. You need an antidote, and you need it like yesterday.
So, how did we fight back? Well, for a long time, the medical community had a trusted go-to response, a key player in the fight against this poison.
And here it is, sodium thiosulfate. For decades, this compound was an absolute cornerstone in treating cyanide poisoning. Its job was simple, direct, and life-saving: neutralize the threat.
Now, what's interesting is that sodium thiosulfate wasn't really a lone wolf. It was actually the grand finale in an older three-part treatment kit. A patient would first get amyl nitrite, then sodium nitrate. Those first two drugs were all about buying precious time. Then, sodium thiosulfate would come in as the cleanup crew to finish the job and detoxify the body.
Okay, so how does this thing actually work? This is where the chemistry gets really elegant. It's like watching a perfectly choreographed rescue mission at the molecular level.
But before we get into the nitty-gritty, let's look at the end goal. The whole point of this entire process is to turn that deadly cyanide into this compound right here, thiocyanide. Why? Because thiocyanide is way less harmful, and it's something our bodies can just easily filter out through the kidneys. Game over for the poison.
The process itself is surprisingly straightforward. So first, you've got the deadly cyanide wreaking havoc. Then, in comes sodium thiosulfate, and it acts like this amazing detox partner. It literally just donates one of its sulfur atoms, and that simple donation flips a chemical switch, instantly converting the cyanide into harmless thiocyanate. Just like that, poison neutralized.
So, at this point, sodium thiosulfate sounds like the perfect hero, right? Case closed. But, every good story has a twist. And in the world of medicine, the goalposts are always moving.
And there it is, the twist, a direct statement from modern medical literature. Despite its clever chemistry and its history of saving lives, sodium thiosulfate's time as the #1 go-to treatment has passed. So, what happened?
Well, what happened is that the whole strategy evolved. That older method was that complex three-drug dance we talked about. The modern approach, it often favors a single, much faster-acting headliner, like hydroxycobalamin, which is basically a form of vitamin B12. Now, sodium thiosulfate hasn't vanished, not at all. It's just moved into a supplemental role, kind of like a trusted sidekick to these newer, faster antidotes.
And part of that shift is because, well, our old hero wasn't without its own issues. Administering it wasn't always a smooth ride. It could cause a burning sensation, nausea, and some pretty nasty muscle cramps. And while that's obviously way better than the alternative, it pushed researchers to find better, gentler options.
And there are other tricky situations to think about too. In pregnancy, for example, doctors might lean towards other treatments because of potential risks. But of course, if the mother's life is on the line, it's absolutely still on the table. It just goes to show you how complex these life or death decisions in the ER can be.
So where does that leave us? What's the big takeaway here? Is this just a story about an antidote that got outdated? No, not at all. It's actually a story about something way more important, and honestly, way more inspiring.
The journey of this one drug, from star player to a supporting role, is the perfect illustration of medical progress in action. We learn, we innovate, and we refine. We find a solution that works, and then we work tirelessly to find an even better one, something faster, more effective, and safer.
So here's the crucial point. Sodium thiosulfate isn't some forgotten relic. It's a foundational chapter in the story of toxicology. Understanding its role and its evolution teaches us a vital lesson about how science is a process of constant improvement, always standing on the shoulders of what came before to create a better future.
And that really leaves us with a fascinating thought, doesn't it? What are the common, life-saving treatments we totally take for granted today that are just one breakthrough away from becoming tomorrow's old-school but absolutely essential heroes in the history of medicine? Makes you think.